present his, I think by title, it is, I think, quite interesting because the Geiger school concept and education in Japan is the one that we can learn from. How the school has been able to make themselves innovative. I think I would like to learn from Professor Ito, research and development experience. I think all the chance will be yours, Professor Ito. Thank you.
Oh, for a moment, so yeah. I'd like to.
Oh yeah, yes, please. Just take your time.
Okay.
Yeah.
So can I share? Can you see?
Yes, of course.
Yes.
Excellent.
From the beginning, so can you see the title?
Yes, of course. Very clearly.
Japan, okay?
Yes.
Can you hear me?
Yes, of course. Very crystal.
Professor Aceh Surya.
Yes, thank you.
My students, so you allowed me to let students attend this conference. So another room. Can you hear me? My video is floating. Yeah, okay.
Yes, we can hear you very well. Yeah. I think you'll find the hard time for the connection. Prof, the connection has been somewhat ended.
I think he's lost his connection, sir. Maybe.
I think so. So I would like to let him reconnect.
Yes.
Yeah. So, Ibu Hilda, the chairman. Yes. So maybe before we continue with Professor Takashi Ito, we may be able to say hello to other 4 international participants.
Yeah, there are some participants from Mongolia and also
Mongolia. Wow.
Yes, but
yes.
I try to find in this participant list.
Yeah.
Hopefully, she or he already here.
Oh.
Yeah, wait. Actually, I
just mention the name. That's all.
Yeah. Okay. Wait, sir. Okay, I try to find Zoe Lindsay.
Oh, Jones, yeah.
Zoe Lindsay. He's from City University of Mongolia.
Mongolia. Zoe.
Zoe,
Yes,
are you
Joe.
here? Are you here, Zoe? Zoe Lindsay or Liu Sufan?
Yes, Liu Sufan. Do you hear? Are you there? We would like to say hello.
I came back.
Okay. Welcome back, Professor.
Welcome back.
How should I do? So when our student tried to introduce themselves, so the connection is down. So maybe during my talk, if possible, so I'd like to introduce them. So
would you reshare again, please, Prof?
Okay. So I directly share my screen. So, oops, this is not so good. I'd like to, oops, not so good. From the beginning, I'd like to change this situation. Okay, so it takes a time. Sorry.
Yes, take your time, Professor.
Okay, so
we have plenty.
Yeah, I'd like to explain the situation in Japan before showing
Yes, please.
My files. So yeah, quite recently the cases of number of patient are decreasing. So for example, yesterday the total cases in Japan are now 77
per day.
No, yeah, yesterday. So even in Japan,
Yesterday,
in
sorry.
Gunma Prefecture, yesterday it was one cases only.
Okay.
There was only one cases, one
77.
case.
All over Japan.
Yes, even in Tokyo. So surprisingly, 5, according to the newspaper.
Well,
Five. So infected person appeared. Only 5 cases. So, and so the situation in okay, so gradually I'm now dealing with.
Yeah, just take the time.
So the education in Japan is a little bit different from other country nowadays during pandemic. At the beginning of the pandemic, last year to 2020, the student did not come to primary school and high school, junior high and senior high school. But gradually they came back to their schools.
Today already come back.
Yeah, today, yes. Last year they have already come back to each school. But
all of them?
Yeah, but there are some rules, so separated to groups or something.
Okay.
But nowadays, they have already come back completely, and except university students.
Oh,
I'm not sure. I don't want to tell you are kidding, but so government did not trust university students. So they, but now they are coming back. So as you already mentioned, hybrid class now continuing.
Hybrid. Okay.
Yes. And so, oops, I'd like to use the slideshow, but how can I use this one? Okay. For a moment, I'm not so good at using.
Neither
this is another file. I made a mistake. Okay, so I'd like to talk about the education during the pandemic, and especially focusing on at present. High school education, focusing on high school education and university classes. Okay, so
yes,
from the beginning, maybe, can you see?
Not yet.
Not yet. Oh my gosh.
Not yet. Sorry.
How should I do?
Maybe.
Yeah, I have already opened this one, and
yes, you may be able to stop share at the first place and then do it again.
Okay.
Please.
How about this one? Okay.
Yes, yes,
Okay, so
already
I'll
there.
continue. I'll
Yeah.
continue. Okay.
Yes.
So I'm going. The title of my talk is Giga School Concept and Education in Japan. So through the mathematics study point of view in high school and university. So, okay. The specific area of my study is operator algebra in mathematics. However, after discussing the topics with you and with the organizers, I decided to talk about the Giga School concept at present in Japan, and also talk about the teaching way in university.
Yes.
Okay.
Splendid.
So
yes.
The first, I'd like to talk about the part one. I talk
global innovation gateway for
yes. Giga is not a capacity of the device, or the megabyte or gigabyte. It is totally different, the meaning. But Giga school concept is Giga is a global and innovation gateway for all in Japan. It was launched in 2019 by the Ministry of Education in Japan.
Okay.
The purpose of this is to realize an educational ICT environment for every student without secluding the diverse ones. In other words, each student terminal must be standardized.
Okay.
It means each student can use terminal, for example, iPad or some another tool, individual. It must be very costly, but our government and the local government has already decided it to pursue this initiative. The reason why there were several issues as of 2019. Firstly, I'm talking about Japanese situation. Okay. Firstly, school ICT environment maintenance is fragile and critical. There is a large disparity in environment maintenance between regions. Some area are very behind, and the big town is advanced. Secondly, the use of digital devices at school is the lowest among 37 OECD member countries. OECD has already explained the key difference. Dr. Usaini has already used a lot of reference for, so I don't need, there is no need to explain the OECD, but for my student, I'd like to explain Organization for Economic Cooperation and Development.
Yeah.
So it showed some assessment. It is called Program for International Student Assessment. It is so-called PISA. We use the statistics 2018. So it said Japan needs use of digital devices at school is the lowest among 37 among 37 OECD member countries. And thirdly, children's use of ICT outside school is more recreational than learning. ICT use outside school is below the OECD average when studying, but it is above the OECD average when playing. For example, gaming and chatting. The playing game time are very long for children. So government use the strategies for Giga School concept as follows. Having special support by integrally developing a high-speed, large-capacity communication network through each student's terminal with the help of the national and local governments. And by creating the best incorporation of Japanese educational practices and cutting-edge technology, we can maximize the full potential of our teachers and the students themselves. Here is a formula. So, accumulation of educational practices times ICT is equal to enhancement of learning activities from the perspective of independent, interactive, and deep structured learning. The green part is our hope to achieve, to be achieved in the future, okay? But for this, I have this formulation is given by the government, Ministry of Education. The present, I'd like to explain the present situation. Aiming the next generation of schools and education site, it was initially planned that each student terminal of the Giga School concept would be installed by 2023, 2 years from today. But due to the spread of the coronavirus infection, maintenance progress needed to expand more than as planned. So as a conclusion, this July, as of the end of July 2021, about 96% of local governments have completed the maintenance of terminals. So it means students, almost all students can use, for example, iPad or another Chrome device individually in a class, you know. So now I would like to show you all a real math class at secondary school to explain the concrete example of Giga concept at present. Okay?
Yes.
This is a junior high school attached to Guma University, 3rd grade. Their age from 14 years old to 15 years old.
Yes.
So in each class, how many? 40 students. There are 40 students in each class. But attached school is, I heard, attached school is very rare in the world. But in Japan, we have attached school to each university, basically. We can go to the school and to help teachers and get some information directly from the high school. We also have a primary attached school also, but this time I'd like to show some class in junior high school attached to our university. So now I'd like to give you a problem. So first, at the beginning of the class lesson, teacher posed this problem, and this problem is shown on a display. Can you see the display behind of the teacher? Behind the teacher?
Is it a screen?
Yes, it's a screen, but it is a display. It's a monitor.
A monitor, yes.
Yeah, monitor. He used the application Loiro Note School. I will explain later this application. Okay. The problem is there is a square with a side of h centimeter, A, B, C, D. Point B colored red, start from B, left down point B, and move
Yes.
from B to D through capital A point. It means on side BA and side AD, from starting from B to A to D. P moves
Right.
from B to D, okay? And point Q start from B and move it on side BC. Q is also red color, you know, and P moves at 2 centimeters per second, and Q moves at 1 centimeter per second. So P is faster. So the question is, let's draw a graph, the area of the triangle BPQ. So where y square centimeter is the area of the triangle BPQ after x second. So students try to write the x-axis and y-axis and draw the graph. Okay. Here is a lesson flow. First, okay. So can you see every student in this school, every student has iPad on each disk. Maybe you can see the iPad. And teacher has already sent the problem from his iPad to transfer the problem to each student. So student, there is no need to see the display, but teacher had already shared the display and explained the situation by using the Blackboard. And one student used a keyboard, and another student used a digital pencil, and one student used his own notebook. As they like, they can solve this problem. And next, teacher explained the problem in detail and send a grid sheet to
green sheet, yes.
grid sheet. So you can see it on a display. And the left down part, so student had already received the grid sheet. And some students received it as a paper, by the paper. So because he doesn't like to use iPad, so in that case, he can get a paper. It has already printed. Okay.
Yes.
And so this is some explanation done by teacher. So he used a display, and like there's a triangle, small triangle on the right, and on the left there is a bigger triangle. The area is getting bigger and bigger. The area of the triangle are now bigger and bigger, and a student gathering data of the relationship between X and Y. Okay. X is a second, Y is now area. Okay, so
Yes.
this is this is the most important part.
Step.
After solving the problem, students send their answer to teacher's iPad. So teacher can see the student answer, all of the answer simultaneously. This screen explains that half of the answers are now corrected. So finally, there are plenty of answers. So the teacher chooses a good answer and typical answer from the students. There are 4 answers, and teacher asked to the student, so could you explain your answer?
4 different answer, yeah?
Yeah, different answer. Similar but a little bit different. Okay, so finally, so I skipped the student answer, but after that, teacher explained their answer correctly and explained it in detail, and the right side is the goal of the graph, which is this is a complete answer. This is the step to use their gadget. Roy Note is very useful, not only mathematics, in any subject. For example, English or Japanese language, history, another science.
Social science also.
Yeah, in this school, so they use Roy Note, so they can get the information or answer from the student simultaneously. And next, the teacher gave another problem. This is much more complicated, but the step is quite similar. So I step using the duplicated area. So it is much more complicated, but I skip this problem. And so the graph is a little bit strange, but anyway, they can students can reach the complete answer, and you can see the blackboard. There is all of the data or writing which the teacher taught within 50 minutes. Student can understand what we have done, we have learned in this lesson. Okay. This is a typical example of using the iPad or gadget or terminal initiated by the Ministry of Education. This is an example of GIGA school concept initiative. So now I'd like to discuss about advantages of using ICT. So there are lots of advantages. Be able to see almost all students' thoughts, remarks, and intentions in class simultaneously, as I already mentioned. And distributing and filling out materials has become fast, very quick, just 1 second. The teacher shows the problem to each student. And the possibility of having a paperless environment. I'm not sure several students did not use any papers. I noticed when I attended the class. Okay, it can be associated with other subjects. So teacher can share many files with another subject. And finally, that is a very good advantage, easy to accumulate and easy to evaluate. Because during the class, so teacher has already known what answer was given by each student. Okay. Here is the disadvantages of using ICT. It will take time for teachers to prepare their lesson plans and materials, you know? And there are several difficulties. Difficulty transferring information into notebooks. Some students don't like to use ICT. In that case, so to some very smart student, I asked he can solve a very good answer, but I asked him, don't you dislike to use iPad? No, I like to calculate on my notebook. In that case, every information has to transfer to his notebook. And difficulty to use when spreading various materials. It means iPad or display is very small. So in some cases, we can use many various materials simultaneously. So in that case, we cannot open all of the materials. But if it is a paper, we can open it. Well, it's much better when we use papers. And the last one is a possibility of losing concentration in other subjects and apps. Okay. So now I'm going to the second part, part 2, university math class. As I already mentioned, during the pandemic, university students have not been allowed to study on campus. So professors used Zoom or other apps to teach their classes. But nowadays, so it becomes hybrid. But almost longer than 1 year, I use Zoom. I would like to introduce the ways of online math teaching using the digital apps. In a small class, I use Jamboard to discuss. So this is a Google has already banned it. And for the in the big class, I use digital paper. It's a sort of tool. So, but it becomes a blackboard instead of PowerPoint or something. It is okay. Anyway, what is Jamboard? So here is a word seminar. It is in Indonesia, seminar has another meanings, but in Japan, seminar is called zemi, seminar. So seminar. So it's a very small group to graduate from university.
Yes.
Before, especially in math, student must prepare a lot, and each student explain some theorems or examples instead of teachers.
Jamboard, yeah.
Yeah, so Jamboard becomes a blackboard, and the black pen is written by a student. He solved some problem using a black pen, and some of them, some colored pen is done by myself, and some of them were used by another student. So we can write as we like on the same paper. Usually,
it is a real paper or a screen?
A screen. Yeah, it's on a, yeah. Some students use iPad. Some student use iPhone. I use Windows PC.
Okay. Okay.
So it is directly if you open the Google, so there is some application named Jamboard. It's free. Okay, so this is Jamboard is used for
it is available in Google.
Yeah, yes, it's free. It's for free.
Okay.
Yeah, there is a 9 dot. If you click the 9 dot, so you can find the Jamboard, I think.
Okay.
Okay. So next, this is an ordinary class. I use the digital paper. And this is a handwriting. I don't like to use PowerPoint
digital paper.
Yeah. This is handwrite. Yeah. From the beginning, like a classroom in ordinary class, I used digital paper. This is here is to prove some famous formula. What is the formula to get pi half? Anyway, I use digital paper. So in this class, the student number are more than 50. But I have a lot of stress to teach using Zoom, because first, my university, well, most of the university doesn't allow to use video, and basically they have to mute, because the more than nearly 1,000 class simultaneously going. Yeah. It means if they use their own video unmute, so the server will crash down. So so basically students should be on mute, and without using any video.
Otherwise, it is noisy.
Yeah. So it is something like a discussion with word, no reaction. So I catch up with some idea. So I asked several volunteers. They 5 or 6 students in a class. So they
small class.
it's not small class, even in the big class.
Even a big. I see.
So I asked to let them. I asked 5 or 6 students to be a volunteer. They will do unmute. They can open like this situation. Professor Ache Sriadi are now using the microphone. So like this, 5 students use a microphone. So in that case, I can communicate very smoothly. Okay, do you understand so far? Professor Ache or something like that. In that case, some students said, no, I can't understand. Okay, I'll explain again. Why in detail? Which part don't you understand? Something like this.
So this is individual.
Individual, yeah, that's right. So now I'm using PowerPoint. If it's possible, I'd like to use. I wanted to use digital paper, but I have I don't have so much time. There is some limitation. So using PowerPoint, I'd like to show you the way. How did I teach?
Okay.
Okay. Pythagorean theorem is very famous theorem. All of you know. So in a right triangle, the longest side is C. Let's see the longest side on the right in a right triangle. So in this case, a squared plus b squared is equal to c squared. Right? It is very famous. So the Pythagorean triple, maybe this is a new word for you. What is a Pythagorean triple? The integer solutions to the Pythagorean theorem, a squared to plus b squared is equal to c squared, are called Pythagorean primitive triples. Technically, we need some condition. If GCF, greatest common factor or greatest common divisor of ABC, is 1. So maybe there are very famous Pythagorean triple, 3 and 4 and 5. This is the most famous Pythagorean triple, I think. I'd like to, I want to use I can't write, so how can I?
It's backward.
If I use a slide, can you see?
Oh yes, of course.
Okay.
This is different files, right?
No, same file. So the first, okay, I should go to the, how can I go?
Which slide?
Okay, yeah. So this one. Okay, maybe I can write.
Okay, good. Just move forward. This is,
yeah. So can you see 3 squared plus 4 squared is 5 squared?
Yes. All right.
This is the best famous triple.
This is your handwriting, right?
Yes. Now, like this, I use the digital paper in classroom. So, and also 5 squared plus 12 squared is equal to 1. This is 13 squared, you know. Let's find out the Pythagorean triple as much as possible. So, okay.
Okay.
So here is an idea. This part, plus 1, 4 plus 1 is 5, and 12 plus 1 is 13. So what is the blank in this part? Oops. I'd like to use later. So blank part must be 2n plus 1. Okay. If you, this part is, by using this formula, if 2n plus 1 is k squared for some k, then we can get a Pythagorean triple, because if 2n plus 1 is a scared number, then, but we have to be careful. K must be an odd number, because even number times even number must be an even number. So left side is the odd number, so K must be an odd number. For example, if 2n plus 1 is equal to 3 squared, then it is easy to calculate. N is 4. This implies 3 squared plus 4 squared is 5 squared. Like this, if 2n plus 1 is 5 squared, then n is 12. So we can get a new triple. I have already mentioned, but here is, if 2n plus 1 is 7 squared, 7, 24, and 25 is new Pythagorean triple. And also assume 2n plus 1 is 9 squared, then calculate the 2n plus 1 equal, sorry, it's messy. We use the 2n plus 1 plus n squared is n plus 1 squared. if this part is 9 squared, easy to calculate n. In this case, n is 40. So this implies 9 squared plus 40 squared is equal to 41 squared. This is correct. This is a new Pythagorean triple. But in this way, not only adding one number like this, maybe we can find another triple, but it is very slow way to find. Here is a very important formula. There is a fundamental formula for generating Pythagorean triple ABC. There are two statements. Given an arbitrary pair of integers, positive integers m and n, with m is greater than n, which are coprime. Coprime means greatest common factor or divisor of mn is 1. For example, 6 and 4, GCM, m is 2. Okay. 6 is 2 times 3, and 4 is 2 by 2 times 2. So greatest common factor common factor is not multiple. Common factor is 2. So under this condition, one more, not both odd. Under this condition, m squared minus n squared, 2mn, m squared plus n squared is a Pythagorean triple. But this part is much more important. Conversely, on the other hand, given an arbitrary Pythagorean triple ABC, then there exists a pair of integers m and n which satisfies a similar condition, and A can be written m squared minus n squared, B can be written n to mn, and C equal m squared plus n squared. This is so example. Here is the example. If m is n, m is 2 and n is 1, so m squared minus m squared. This is just a simple calculation. We can get like this. And for example, Sakurai-kun, can you answer? Sakurai-kun, I'm asking to my students. And what is the number? So here are lots of triples, new triples. Okay, so what do you put a number in this bracket under 6?
The number is 1.
So in this case, what is m squared minus n squared?
35.
35, and the next blank is
12.
6, 12, and the final number is, what is this? 36 plus 1, 37?
Yeah.
Okay, correct. So something like this, we can get all of the Pythagorean number in this way. But surprisingly, there is another way to generate the Pythagorean triple. Maybe I'd like to call that way. We are going to introduce the magical matrix P, which manufactures all Pythagorean triples. What can I say? Yeah. So there is some reason, but I skipped the proof, of course. Only using one matrix, we can manufacture or generate all Pythagorean triples. Okay, for example, if you remember the operation of the matrix, Sakurai-kun, again, could you fill out the blank part?
Okay.
First blank, what is this?
3,
3 and
8,
8,
10.
10. So in the, now what is the number over above 20?
21.
21. It means,
21.
okay, 21 squared is 441. So
Is
it
it-
is,
It is 3, 8, and 6 arbitrary number.
pardon me?
It is 8, 3, 8, and 10 is arbitrary, or there's something to resolve.
So this part is operation defines this is a three-dimensional, in mathematics, 3, 4, 5 is a three-dimensional vector. So
Oh,
this
this is a,
matrix act on three-dimensional. So just
Mhm.
triple is okay, maybe easy to know. You can, so AB like this. This is a two-dimensional.
I see.
But yeah, here is a vector 3, 4, 5 like this, and the matrix P act on this vector. So the 3, 4, 5 transfers
Yes.
to another vector. And this is a
Sure.
key point. So starting from the sum Pythagorean number, by transferring this matrix, we can have a new Pythagorean number, a triple. And this is one way. And if you add minus here and also here, this two vector is also a Pythagorean triple. We start from 3, 4, 5, and the first component we add a minus in B case and C case in the middle number. So 4 has a minus number like this. Okay. Next, I use the 4, 5, 12, 13. In this case, 5, 12. I calculate this one, 55. Okay, and finally, the midpoint, this one, what is this? Sakurai-kun.
28.
28. Okay, so all of them are new Pythagorean triples. Okay, so and we can make trees starting from this one. We have 3 sons. 3, 4, 5 is a parent, and 3 number. I denote this is A, B, C is children, and for each children in the future they become a parent, and they manufacture 1, 2, 3. Each Pythagorean number, after operated by P, they become Pythagorean numbers. So this is a very beautiful trees. So we can get all of the Pythagorean numbers in this way. I'd like to introduce my student again, Sakurai-kun.
Hiroya.
Hiroya, could you
Hi, Sakura.
show your face and with your classmate?
Okay. じゃあみんな準備。
Yes, Sakura.
Hello.
Hello.
I'd like to introduce our
Yes.
9 students.
Okay.
Oh, 9 students. Oh, wow. Thank you.
They are now in the same classroom.
Yeah.
Oh, yeah. Are they your students?
Me?
Professor Ito?
Yeah.
Are they your students?
Yes, my students.
I see. Wow. Welcome, Hiroya Sakura. Hi.
So can you use your video?
Yeah,
Have you already used it?
yeah, already use it.
I can't see you. But anyway, so if you talk about, okay. Anyway, so another student say hello or selamat pagi.
Iya.
Oh, selamat pagi.
Selamat pagi.
Another
Terima
student
kasih.
yeah, greeting for you. Anyway, so I'll stop here my talk. Thank you so much. Terima
Thank
kasih.
you.
Hatur
Terima
nuhun.
Hatur nuhun.
Arigatou
Arigatou gozaimasu.
Arigato gozaimasu.
Yeah, that's all.
Thank you.
Thank you very much.
Wow. So before I'm open to the participants, so I would like just to say thank you so much for your very interesting presentation, because you know this international seminar, ICSST, the first ICSST is already at the first place. The two keynote speaker already presented the more general issue on education, science and technology and innovation. After this, thank you so much, because Professor Takashi already plunged into more detail and more operational matters. This is very important. And in the future, our seminar for the second ICSST, I think it has to be more and more operational, like Professor ITOH has presented. Thank you so much.
But
There is a lot of things. Yes, yes,
I would like to say one thing. So for the education, the most important factor is equipment or facility is not the main factor to educate students, I think. What is the most important factor or component is a teacher. I think good education is almost equivalent to having a good teacher. So in the university, we have to raise good teachers. What is good teachers? So they should have plenty of knowledge and good teaching skills and good communication with students. And I'd like to emphasize passion for education. So I think to teach students. Yeah. Okay. That's all what I want to say.
Do you have any application for this kind of model of teaching? Because of course we need some kind of digital devices, to be used and to be included. But I think the program that you maybe specifically designed for this application of these models, do you have some?
In some sense, still we are beginner to use. Last year, so because of the by the pandemic, I have to teach Zoom. At the time, last April, we struggled how to use Zoom. Nobody used Zoom. So in some sense, this is on the way to how to brush up our skills to use ICT. But nowadays, I now managed to use ICT so effectively to have a volunteer to communicate with students. But I don't have a good answer for your question.
You do have. Well, the last question from myself is that you said that these models can be applied to other subject matters.
Yeah.
Instead of other than mathematics, but maybe you can have some kind of general models.
Oh, okay.
Yeah, just to be applied in certain subject, because myself is not specialized in mathematics. I am in social sciences,
Oh, okay,
in social
I see.
science. I'm economics. So this may be also very important to be used for the economic subject matter.
Okay, I see. Thank you.
What do you think? As long as there is some kind of general model you can provide.
Okay, thank you much.
Application.
Okay. Applications.
Yeah, do you have some kind of that models, a general model to be
Yeah,
to
we
be
are
applied
now
in other
discussing
subjects?
about it with our colleagues. Yeah, it's very important. But
I know.
yeah,
Yes.
and it's still on the way to
Okay.
spread such an idea or policy.
Okay, because I know that you already engage in research activities in Yogyakarta University,
Yeah.
and you have also published manuscript and books.
Yeah.
So you may be able in the future, because your Pythagorean triple is very important. You may be able also to get cooperation with us, with our university, UNIS,
Okay,
in the future. Thank you so much. Thank you so much. Okay, I think we have come to the end of the presentations of Professor Ito.
Yeah.
Very interesting. And this is something new for us, at least, in order for us to be able to develop further. So we would like you to get in touch with us, because we have here in Faculty of Mathematics and Science here. So you may be able also to collaborate with us. If you have some more ideas, some more model innovations, you may be able to get cooperation with us. Thank you.
I see.
Ms. Hilda, do we have any more time to have some question answer with the audience?
Pardon, sir. We have one keynote speaker for Dr.
Also already